Hello, again, my name is Lipat, and I'm a third year computer. Hopefully my audio is fine. And I'm a third year computer science student. And I think I'm the last presenter, so I hope everyone's not too tired yet. So, but anyway, yeah, let's just get on with it. So let's start. The Center for Learning and Information Resources is one of the most important facilities of MCL. It's a place where students find a quiet place to study, wait during their vacant periods, and find resources for their study. And just an aside, when I say CLEAR or Center for Learning and Information Resources, I'm referring to the library of the CLEAR. So that's library and CLEAR is synonymous for MCL. And when I refer to MCL, I'm referring to Malayan Colleges Laguna, which is my college. And so yeah, it is one of the most important facilities in the CLEAR, and students use it for various uses. However, there are two problems with using the CLEAR. First, visitors waste their time and energy going there, only to find that there are no vacant seats. So they come from very far places. They go to the CLEAR, but they immediately leave because there are no available spaces. And second, the operations of the CLEAR is affected by COVID-19 safety protocols, such as social distancing, as well as the government is also regulating the number of people that could be inside a library. And because of this, we want to develop a system called Sparse. And what Sparse does is that it first determines the room occupancy of the CLEAR. Second, it displays this information through a website so that visitors could avoid going to the CLEAR if it's full or crowded. And for librarians, they could determine whether the current room occupancy of the CLEAR is within the capacity set by the government. And lastly, it makes sure that students will get a seat. And because we want to determine the room occupancy of the CLEAR, we tried taking a look at related literatures of the possible ways to do this, and we found out that the state in the art in people counting is, I apologize. The state in the art in people counting is by using computer vision techniques, and from these we formulated our statement of the problem. First, the first problem is what computer vision based people counting algorithm would best identify the room occupancy of the CLEAR. Second, what features are needed to be implemented in the system? And third, how useful would the features of the system be for our target users? And our target users are visitors, which may be students, they may be faculty, or they may be staff of MCL. And our second target user are librarians or CLEAR staff. And from these problems, we formulated our objectives. So our first objective is to identify the most appropriate computer vision-based people. It's quite a mouthful. Computer vision-based people counting algorithm for the system. Second, we want to identify and implement the features that would be useful for visitors and librarians. And knowing these features that we want to implement, we want to evaluate whether or not those features are really useful for them. And starting with the first objective, we identified the most appropriate computer vision-based people counting algorithm for the system by identifying the different computer vision-based people counting methods, and then we trained those models using the Scott head dataset, and then we evaluated them by comparing their processing time and root mean squared error. Do note that testing and training are two separate like parts of the dataset. And to identify the different computer vision-based people counting methods, what we did was we again did a review of related literature, and we found that there are three commonly used object detection models which could be used for people counting. These are faster RCNN, single shot detector, or SSD in short, and RetinaNet. And from these, we trained this model, and here are the results that we got. So at the left side is the validation loss per epoch of each model, and at the right side is the total training time per model in hours. So, yep. And then, for the testing step, we compare the average processing time of each model, and we compare the root mean squared error of each model. You could see that in the average processing time of each model, the trained SSD model had the least processing time, while RetinaNet and fast RCNN had higher but similar processing time. But all of them are acceptable because they have low because their processing time is in less than seconds. It's in milliseconds. And for the root mean squared error of each model, unfortunately, the models that we trained, they performed worse than the pre-trained models. But because for various reasons, this may be because the model, this may be because the model could not fit the data set, because we had to use larger images to detect smaller, because pictures in libraries have they need to detect smaller heads, so therefore we need a larger image, and it might be because of that the model could not fit the data set. And but nevertheless, we selected the faster RCNN model because it had the lowest root mean squared error. And then now that we identified that the most appropriate computer vision based people counting algorithm is the pre-trained faster RCNN, we now identified and implemented features that would be useful for visitors and librarians. And we did this by collaborating. We did multiple interviews with librarians and a student who commonly uses the CLEAR. And then once we identified the system requirements, we implemented and tested them. And here's an overview of how our system works. So it first gets the camera feed from the CLEAR, and then it puts it into the computer vision model, which counts the number of people inside the CLEAR, and then it inserts it into a database. And then whenever a visitor or a CLEAR staff requests data, it queries the database. Now that we have these, the features of the system include the room occupancy chart, interactive suggestions, library information, and seat reservation. And in the next slides, I'll be showing a couple of screenshots of these features. But I'm going to go through them quickly because for brevity and for time. So here is the interface for the room occupancy chart. This one's for the interactive suggestions. So I hope you can see it. It's quite small. And then here is the interface for the library information. And then the interface for the reservation. And then for the features of the librarians includes room occupancy information, report generation, summary of reserved spots, change effective capacity, library information management, and account managers. Maybe you could ask me later if some of these are not too clear. But here are a couple of screenshots of these features. So here is the feature of the librarian where they could look at the current room occupancy as well as the effective capacity. So the effective capacity is the capacity set by the librarians, because of COVID protocols, they must be able to set the capacity of the library. And then here is the interface for generating reports as well as graphs. And then here is the interface for editing the information about the library as well as managing librarian accounts. And now that we have identified the features of that would be probably useful for visitors and librarians, we now have to evaluate whether these features are really useful for our end users. And we did this by conducting a survey on 20 prospective users. And here's a breakdown of the users that we have surveyed. There were 15 students, 3 faculty members, and two of the 3 librarians of the CLEAR. And then here are their evaluations. This one's averaged. So for each feature of the visitor interface, of the features for the visitors, it had a score above 4. 5 means 5 is the highest. That means 5 means the system is very useful for them. Meanwhile, 0 means it's not very useful for them. So the average all features had a score above, have an average rating of above 4, which indicate that all of these features are useful for end users. And then I guess I should mention that that in the interactive suggestions feature, there were some who mentioned that it was too wordy and it was too repetitive. So maybe we could improve on that in the next study. And for the librarian interface, here are the features and the average ratings. And all of them, again, scored an average rating of above 4, which again indicates that these features are useful for librarians. And with these results, we were able to show that the faster RCNN model is the most appropriate computer vision-based people counting algorithm for the system. Quite a mouthful again. And we were also able to identify what features we should implement for the system, aside from the initial things that we want in our rationale. And then we were also able to show that these features are useful for our end users. And through this, our study contributes a system that improves the experience of users using the Clear, a prototype that could be used as reference for future studies and implementations. And we also show how computer vision-based techniques could be applied for this certain domain problem. And but there are some parts of the system that still could be improved. First, for the computer vision model, we recommend using more powerful hardware to train the model for more epochs. So it could be more accurate, and maybe maybe that could solve the problem that we were having with the models, with our trained models. We could also explore different ways to count people, such as YOLO or YOLO masks or CNN. These are object detection models or network-based people counting method, which well, I could get into details of this if you want. But for the system, we recommend that the feature researchers implement the features suggested by the users and put focus on the user interface and user experience, because this was one of the main points of the feedback that we got. And then for those who are looking to implement the system in the future, here are a couple of tips or things that should be considered. First, consider how data should be managed, because the model collects data every 5 minutes. So that's that's what we set it to. Since it collects data for every 5 minutes, it should this could lead to a lot of data stored in the database. So they should consider how data should be collected, and then consider possible concurrency issues. There may be two visitors who want to reserve at the same time, so that's a concurrency issue. And yeah, and then consider synchronization points between the different modules of the system, because failing to do this may lead to erroneous reservations. And that's it for my presentation. And to wrap this up, I'd like to thank RSU for giving me the chance to show you guys my our study. Thank you.
Okay, thank you, presenters. Time for questions. Please, Dr. Jamie, you raise your hand.
Yes.
Okay.
All right, thank you. Thank you very much, Job, for your presentation. I like the application of computer vision for this, for monitoring the people. But I thought you were going to show us a map with seats on it, where you can show if that seat is being occupied or not.
Mm-hmm.
Did you try something like that?
Well, we only had a very, very tight schedule for this project. We'd like to implement some sort of system like that, and it was actually one of the the most suggested feature that we should implement. But due to time constraints, we only had 3 or 4 weeks to complete the documentation papers and stuff like that. So we were working on a tight schedule, which is why we couldn't implement that. But that's a great idea. We would like to implement that in the future.
All right, excellent. I just want to make another 2 remarks. One is that I don't see the advantage really of this system above the a key card type thing. Like in our library at Rangsit, we have a access card, and before entering the library, we need to scan the card. And I know there are some places that use that to count the number of people who are inside the library. Now, that might not be very specific. There might be multiple rooms or areas inside the library. So if your system can provide that information, like specifically how many people are in each room, then I guess that would be an advantage. But that would require having cameras pointing in every corner, and people might start to, feel a bit wary, start feeling like they're being watched all the time. But yeah.
Well, about that, because one of our initial ideas when we were planning this project is that we want to also implement it in other parts of the school. There are some parts, because there are some parts of the school where there's no definite, because for an ID system, you need a definite entry point and exit point. And because we want, in our initial idea, we want to implement this also, we also want to implement this in other parts of the school where it's open, where students can go in and out from any direction. So, but yeah, it has, we also have that in MCL, and well, that might be a cheaper solution than this one.
Thank you very much. Thank you. All the best.
Thank you ค่ะอาจารย์ทศพโอเค
I'll go first then. Following Dr. Jamie's question, and what was the training data set that you used it to train the RCNN? Because I could not imagine what did you do with the network. I thought you must have started off with some images, right? With crowded people inside a room and
I could show
some
the data
numbers.
set that we've used. So it's called. Can I show it? Can I show it now?
Yes, please. I would like to understand this. I didn't quite catch that at all.
All right. So I guess since I'm sharing my screen, I could just go. It's a GitHub repository, and here is the data set that we used. I hope this is fine. And here is the data set. Here's what an image looks like. It's like a. I guess I could open this one more time. No, that doesn't. There we go. It doesn't really solve it. But anyway, here's what the data set looks like. It has bounding boxes for each head in the picture. So we use that model. So we use that data to train our model, the bounding boxes. And then from that, the rest.
Did you label all the heads yourself, or did you use any automatic software to label the heads?
Oh, this data set is actually available. It's actually readily available. It's by another author. So this
you didn't do
1,000
any label yourself?
Yes, we didn't do, because because of time constraints we couldn't. But we'd like to actually get data from the clear when we had because we couldn't go to our campus because of COVID restrictions. But in the future we'd like to get actual data and label them ourselves. But yeah, we used this data set because it might be good enough because it has like thousands of images, and each image has like 10 to 30, I think, or 5 to 30, something like that, or 5 to 100. I don't know. I'm not quite sure.
And my another question is, you showed the training error in terms of root mean square error, and what was that correspond to the average error in terms of number of heads in an image?
Yes.
So you be talking about the error of 22 people. So that is quite large though. Is there anything that you can do? Is it the best that you can do, seriously, with all those networks that you mentioned about? I thought it would be a lot better than that. I remember sort of like pinned down to one single figure.
Yeah.
You see.
Yeah, I get your point. And that's actually what we thought when we got the results. When we compared it to the baseline pre-trained models, we were kind of disappointed that it performed worse. And we think that if we were given more time, because again we only have like 1 month to develop the software, do everything, we could probably improve our model so that it could be much better than the pre-trained models that we had. And there are like a lot of things that we could do for that. We could make our own architecture, although the current ones are pretty good. We could create our own, or use better hardware, or use another data set that could be that maybe is better for this type of task.
Are you now limited? Are you now limited by the hardware or by the software at the moment?
Well, it's kind of a mix of both. First, for the hardware, we're limited because the hardware that we're using here is Google Colab. So we don't own that hardware, and we can't really really benchmark if it's really, because Google Colab sometimes rates your processing speed, your GPU speeds and stuff like that, which is why we can't really consistently have a high speed. And for the software part, we couldn't really, they're like the data set, with our current model, we are set up with how we train the model. We couldn't really reduce it yet because we didn't have enough time as of now, but maybe in the future, yes.
What sort of the pixel size in the image we talking about here? 200 by 200 pixels?
Well, we used because for librarians, if you take a look at a library, or if you were to position a camera in the library, you'd require a full view of the library. And of course, since you're looking at the full view of the library, it requires detecting small heads. it requires detecting small items in the picture, which is why we couldn't really use like the typical object detection or image object detection sizes up to 300, 200, and stuff like that. We had to resort to a higher
Camera definite
higher
resolution.
yeah, high resolution to
Resolution.
detect smaller objects. So I think that's like one disadvantage of using a computer vision model for such a big area.
Okay, thank you. That's all for my questions.
Okay, thank you. Next question, please. Actually, we have another audience. Yeah, Dr. Jamie, please.
Sorry, yeah, I just wanted to make a suggestion there. Yeah, you were saying that it's a limitation of the computer vision model to have to use like smaller images than are required, but you could like crop segments of the larger image and put them through like in a one by one type of thing, or you could put them through as a stack of images. And because you're only like sampling every 5 minutes, then you should have plenty of time for the GPU to run, you know, even if the processing time is like almost a second, you know, you still have enough time to process those images.
Yeah, we could, well, I guess that is possible, but I guess one disadvantage of that is like, what if like your tiling or whatever, it like cuts a person's head. So it won't be able to count that person's
Yeah,
but I think that it would be tolerable enough to, you know,
you could work it out. I think you could find a
Yeah.
solution to those problems.
Yeah,
Maybe.
we really think that we could, but you know, just like the time.
Yeah, absolutely. Yeah, I understand.
But we'll
time.
take a look at that
Mhm.
you know, solution. If
Okay,
that'll improve the model accuracy.
Okay, thank you.
Okay, I think I saw another one. Let's your hand.
Yeah, I thought I remember.
MCL.
Question, please. I thought you were raising your hand now.
Yeah, please. Turn.
Actually, I was the one raising the hand, and I am actually one of them. So I just want to add something like for what Dr. Rayleigh was looking a while ago, the picture, the image of the different seats that are available. So they are actually working on that right now, and because of the time and because we cannot really go to the university, to the school itself because of the COVID-19. So that's why it was really a challenge for us. That's why a lot of things are still needed to accomplish. Thank you.
Okay, thank you. Hopefully soon the COVID situation will be all better and you can get back to get some more data for your system.
Yes, thanks.
Okay, thank you. And Dr. Safan, do you have any questions?
Right, it just come to my mind that I like to know what are the process of the verify, how you verify the design of your system. Can you elaborate that?
All right, so you're talking about the user interface, am I correct?
Yes.
Well, for this study, we're not really looking at the user interface yet because we want to focus on the user experience of whether or not it's really useful for them. That's what we are focusing here. But so for this study, we did not yet consider the user interface. Although I would admit that probably the user interface would probably affect the usefulness, but yeah, we did. It's currently outside the scope of our study. But yeah, yeah.
Okay, so thank you.